Welcome to Chapter 3. Now, Chapter 3 is all about inequalities. We're going to start with the basics, really, and then we'll move on kind of like we did with equations, where you have one-step, two-step, multi-step, all that good stuff. And we'll end up at compound inequalities. So today, we're just going to work on how do we find solutions of inequalities and how do we graph them. So we have two vocab words. The first one is inequality. And it's a statement that two quantities are not equal. And then the solution of an inequality is any value that makes the inequality true. So first of all, we need to know what our inequality symbols are. So here's a little chart to help you remember that. We have the less than sign. The less than sign, if you think of it as an arrow, always points to the left. Okay, less than left. That helps you remember it. And then we have the greater than sign, and then we have the less than or equal to sign, and the greater than or equal to sign, and these have the line underneath them. And then we have the not equal, and that's just an equal sign with a line through it. We'll be using these first four, but you should know what this last one means. So, unlike an equation, an inequality is going to have more than one solution. Okay, you know, like with an equation you'd come up with x equals 2. Now with an inequality, it has infinitely many solutions, but there's kind of parameters on what these solutions are. So we use a number line in a graph to show the solutions. So here's just an example of an inequality graph on a number line. Now there's a couple things that you need to know before graphing. First of all is the kind of circle you use at the end point. You're either going to use a closed circle or an open circle. When you see the signs less than or equal to, greater than or equal to, you're going to use a closed circle. Okay? And when you see just less than, just greater than, it's an open circle. When it's closed, it shows that that number that the circle is on is also part of your solutions. When it's open, it shows that the number the circle is on is not part of your solutions. So the first thing you'll do today is they'll just give you an inequality and ask you to graph it. So here I have m greater than or equal to 3/4. So the first thing I have to decide is what sort of circle I'm going to use. Well, since this is greater than or equal to, that means I have a closed circle. Alright, then greater than means that it's going to be graphed to the right. So I'm going to draw an arrow all the way to the right to show that every number that this arrow hits and beyond is part of our solutions. Now they will make you work a little bit harder than that sometimes. Well, they'll have to have you simplify before you graph. So here I just need to follow order of operations. So parentheses first. -1 plus 3 is 2. So this actually says t is less than 10. Now again, open or closed circle. Well, it's just a less than, so that means it's got to be open. Less than points to the left. So that means my arrow is going to go to the left. Alright. Now I have a few more examples here. You can go ahead and do A and C on your own. Alright, they're kind of similar to the examples that I did earlier. I do want to focus here on part B, because this is one that causes lots of issues. So the first thing I gotta do is solve it. So 2 squared is 4. 4 minus 4 is 0. Now you'll notice what's different about this one is that the variable is written on the right side instead of on the left side like the other ones. Now this causes some confusion sometimes. One thing that I've found is easy is if you, every time that happens, just flip it. Okay, put the W on the other side. Now notice when I flipped it, I also had to flip the sign. These two say the same thing. Alright? But flipping it helps you with how to graph it. So let's put 0, 1, 2, And by the way, when you make number lines, I want at least 5 numbers on them. 5 is the minimum. You can put more, but don't put less. So I have a closed circle because it's less than or equal to. And then it's less than. So that has to go to the left. Okay, so when you see one that's written like this, with the variable on the opposite side, flip it and flip your sign. Okay? Now the next thing that you'll see on your homework is they'll give you a graph and want you to write the inequality. So when you see this, you just choose a variable. It can be whatever you want. I usually choose x because that's just what's normally used. Then I have to decide what sign to use. So this is an open circle, so that right away makes it either less than or greater than. And then it goes to the left. So an open circle to the left means less than. An open circle's on 2, so the inequality for this graph would be x less than 2. Now on your homework you'll need to make sure that you draw the graph as well as your answer. That will be how you show your work. Let's look at another one here. Now in this one we have a closed circle and it's going to the right. So if I choose my variable again, closed circle limits me to less than or equal to, greater than or equal to. This goes to the right, which means it's got to be greater than or equal to, and it's negative 0.5. So that's how you do the ones where they give you a graph and ask you to write the inequality. It's kind of working backwards. Okay, then the last thing we have in this section is story problems, and just a few key phrases for you. First of all, if you see the phrase no more than, that's going to mean less than or equal to. It's going to mean this sign, less than or equal to. If you see the phrase at least, that means greater than or equal to. Now there's obviously other phrases, but these are kind of the 2 most common ones. So if you see those, you know right away which sign you're going to use. So here's our first example. We have Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees. Key word right there. Hopefully you notice that. Define a variable and write an inequality for the temperature at which Ray can turn on the air conditioner. Graph the solutions. So let's use the variable t. Now it says define a variable, so we got to say what t stands for. Well, t stands for the temperature. So that's our first step, is to say what our variable means. Now T, the temperature, has to be at least 85. Now in that table I just showed you, I told you that if you see at least, it means greater than or equal to. So we know that T has to be greater than or equal to 85 for Ray to turn on the air conditioner. And then the last thing we have to do is graph this. So if I draw myself a number line, remember I got to put 5 numbers on there. I'm going to count by 5s here just because it's a little bit broader range. I wouldn't have to though. So then I ask open or closed circle. Well, it's greater than or equal to, so it has to be closed. And then it's greater than, so that goes to the right. Okay, so on a story problem you'll see 3 things. 1, define the temperature. 2, write your inequality, or define the variable, sorry. 2, write your inequality. 3, graph. Those are the 3 things I should see on your story problems. One more story problem to look at here. A store's employees earn at least $8.50 per hour. Define a variable and write an inequality for the amount the employees may earn per hour. Graph the solutions. So let's use x, and the x represents amount per hour. So I have x. I hope you noticed again we have the key phrase at least. At least means greater than or equal to. They earn at least $8.50. So our inequality would be x greater than or equal to 850. So then I draw myself a number line. I put 850 on it in the middle. Put my other numbers on here. Open or closed circle, it's greater than or equal to, so that means it's closed. Let's use a different color. And greater than, so once again it goes to the right. So I've defined my variable, wrote my inequality, and graphed it. So as I noted, this is kind of the basics. I know you did a lot of this last year, so hopefully this was all review for you. We'll see you guys tomorrow.